Okay, today we're talking about a special kind of mixture called a solution. Now, a solution is a special kind of mixture. It's a mixture of substances that are completely blended so that the solution looks the same everywhere. Now, as you can tell from what I just said there, it's completely blended. When substances are completely blended, you know something is going to be dissolved, huh? Okay, solutions can be solids, liquids, or gases, but in fifth grade, we're mainly going to talk about solutions that are liquids. Okay, air is an example of a gas solution made of elements including nitrogen, oxygen, argon, and carbon dioxide. Now, think about the air around us right now. Um, obviously it has oxygen in it, and we breathe out carbon dioxide, so it also has carbon dioxide in it. So, but all of the oxygen in the room here, it's all pretty much the same. It's mixed evenly, therefore, it's a solution. Bronze, a solid, is a solution made mostly of copper and tin. But the copper and tin are mixed together well enough so that they've become a solution, but a solid solution. In a liquid solution, a substance dissolved or mixes completely within a liquid. Salt water is a solution because the salt dissolves completely in the water. So sugar water would be the same thing, or Kool-Aid. They all dissolve into the water and make it become a special kind of mixture called a solution. Saltwater solutions occur naturally in oceans and seawater. So the ocean is one big solution because it's made out of salt water. Okay, sand in water is not a solution because the sand does not mix and just sinks to the bottom of the container. So all it is a regular mixture. It's really easy to separate. You could just pour the water through a water and sand mixture through a coffee filter. All of the water is going to come out. You're going to have the sand in the coffee filter. When you investigate how a substance dissolves in a liquid, you are investigating the solubility of the substance. So that's a special property of matter that we've talked about. Solubility is the ability to dissolve. Solubility is a physical property of matter. Solutions can be separated, though. It's just harder. Evaporation is often used to separate dissolved particles from a solution. A salt flat uses evaporation to separate salt from seawater. So, in this picture right here, the seawater flows up into these little rectangles right here, and the sun beats down on the saltwater solution there, and all of the water evaporates away, leaving just the salt, and the people come around and scoop up the salt and they use it. Okay. Now, a paper filter cannot be used to separate dissolved particles from a solution because some physical properties can change. So, if you have a saltwater solution, you cannot just pour that through a coffee filter and separate it. The salt is dissolved into the sugar and it can't be separated like that. It has to be the water either has to be boiled or it can evaporate. For example, the size of dissolved sugar particles changes and the sugar moves through the filter with the water. So sugar water would be the same as salt water. You would have to, evaporate it or boil it to separate it. However, properties such as mass and volume of each of the substances will remain the same. So if you put 2 grams of sugar into 10 grams of water, you have 2 grams of sugar dissolved in 10 grams of water. There are still going to be 2 grams of sugar. There's still going to be 10 grams of water and 2 grams of sugar in the solution. So, Okay, so at that point, if we the only way to separate the sugar from that sugar water solution would be to evaporate the water. So once the water is evaporated, guess what? In the bottom of our container there, all of the water is going to evaporate, but we are going to have 2 grams of sugar left in the bottom of that container. Okay, your teacher places 15 grams of salt in 50 grams of water. When the salt water evaporates from the solution, how many grams of salt are going to be left in the container? We just now talked about a problem like that. So none of the salt is going to go anywhere. It's still there in the container. If the water all evaporates away, you're still going to have the same amount of salt. So you would still have 15 grams of salt. Now, name an example of a gas solution made up of nitrogen, oxygen, argon, and carbon dioxide. Earlier in this slideshow, we talked about the fact that the air around us is made up of all of those different gases. What is the best way to separate a saltwater solution? So with a filter, nah, that wouldn't work. Use your finger, that's just goofy. Condensation, no. Evaporation is what we were just talking about. The only way to separate a saltwater solution or a sugar water solution or any kind of solution is by evaporation. Okay, thank you. That was solutions.